Good morning. This is AJ Javier, your moderator for today. Welcome to another day in the first ever virtual International Design Conference, Philippines. It's officially day 4 of the conference, and I don't know about you, but I'm feeling inspired and energized from the last few sessions. How about you? Were you able to attend those? Comment below or message us. We'd love to hear your experience so far. Going back, it is day 4 of Design Futures, Better Normal by Design. And for today, we've got another big-time design fellow joining us. But before I introduce him, you know the drill. We've got a poll question to get the ball rolling this morning. The question is, in this day and age, would you consider living in a bahay kubo? Yes or no? Interesting, yeah? I'm excited to see the results of this. You may start commenting your answers now, and we'll check back on the results later. As you're doing that, allow me to thank our amazing partners who made this year's IDC possible. Adobo Magazine, our media partner, the British Council, and Buensalido Plus Architects, our official event partners. Thank you again. All right, I think we are ready to introduce our speaker for today. With a passion for creativity and innovation, he champions the use of sustainable solutions in all his projects and has extensive expertise in sustainable master planning, high performance and net zero buildings, including district renewable energy analysis, passive building design, modeling building energy usage, thermal comfort, and indoor air quality conditions. He is a LEED accredited professional that is not only technical expertise, but also recognizes the impact of design for the value and sustainability of businesses. Before forming Alberto Bicol Consulting Incorporated at Cobalt Engineering Integral Group for 9 years, spearheading Cobalt's leading-edge sustainable projects, including several NZE buildings and resorts campus community plans. Allow me to welcome Albert Bicol.
Hi, AJ.
Welcome to DC 2020.
Thank you.
I'm happy you're here, Albert. How has it been in the last few weeks?
It's been good. Sorry, you broke up. Can you repeat the question, please?
Yeah, I was just asking how you are in the last few weeks as far as the work is concerned.
Yeah, we've been working from home like everyone else. It's been a challenge, and but still, it's been good. Work's been good, and I'm excited to talk about some of our latest projects.
That's great. That's great to hear. I'm glad everyone is managing really, really well. So without further ado, Albert, I'll leave you to it. To our audience, make sure to take down your questions or even comment them below so we can revisit them when we have the Q&A. I will pop right out to give you the spotlight, Albert, and we'll catch up after your presentation. So, gentlemen and ladies, Mr. Albert Bicol.
Thank you, AJ. I'm so honored to provide this presentation for everyone and hopefully inspire change and, of course, the reset of, I guess, this pandemic and see how we can move forward strong. Just a little bit about myself. I'm a proud Filipino. I was born in Batangas and I grew up in Canada. So now I'm a proud Canadian. It's evening here now in Vancouver and it's rainy like usual. So yeah, it's starting to rain a lot more. So yeah, this is the typical weather we have here. But anyways, yeah, this presentation is going to be all about net zero buildings. net zero communities and how to build resilient and sustainable communities. We're going to change it up a bit. We are going to create a little bit more of a flavor of the Philippines, and we'll show how we design net zero buildings based on concepts of the Bahay Kubo. And as you could see, some of these things that I will show you, these concepts and projects, I try to keep things simple. And this is the basis of how to succeed on and making things normal. Is you can't make these designs too complicated. Anyways, hopefully we'll inspire a few people to create change, and we'll look after these net zero buildings will align to reduce climate change. And that's the bottom line here, is for us to reset our world, we need to look at the bigger picture, and that's basically climate change. So anyways, we'll continue with the presentation. So just basic definitions: net zero energy. So all the energy that you consume on your building, you need to offset that energy with renewable energy. It's that simple. There's another definition of what we call carbon neutral. Carbon neutral buildings are similar to net zero buildings, but you only offset the carbon footprint of the energy that you're using. For example, in Vancouver, we have hydropower, electricity, and we only need to offset 5% of the electricity that we consume, because that's the carbon footprint of our power. And of course, this is different all over the world. There's another definition that we use here in Canada and North America, is what we call net zero ready. That means we do all the work to design a net zero building, and then the last part is to apply renewable energy in the future. That means it's ready to be net zero. So those are your basic definitions. Now, this is fact. Global temperatures are rising, and what I can do, and the people out there in the building and built environment industry, and our colleagues, architects and engineers, we need to work together to reduce these global temperatures. And it's a proven fact that once we hit 2-degree temperature rise of our planet, that is a very dangerous time. And of course, we all know Greta, and this is, I'm so inspired by this lady, young lady. She's only a few years older than my daughter, and she's out there claiming lives, a better living for her generation. And basically, the message that I get from Greta is, we already have the solutions. When we go through some of the projects that I'm going to show you, these are not difficult things to do. Every architect, almost every architect, every engineer can design a net zero building, right? What she doesn't understand is why we're not taking action. And I think, I will touch on a few points on why we just don't take action. And basically, what she's saying is just stop carbon emissions, greenhouse gas emissions. That's the bottom line. We can't debate it anymore. We can't plan. Why do we need to plan for it? Why do we need more education? Why do we need more research? We just basically have to stop carbon emissions. I did a presentation for a Singapore group for smart cities, and I just want to share this with you. Some of the results is why do you think net zero and carbon neutral buildings are not typical design or built today? One of the major poll answers is we don't have the skills and knowledge. Well, you know what? We do have the skills and knowledge. I actually can't contemplate that answer. And a 16-year-old girl says we have the knowledge already. And then the other poll result is we're just not aware of net zero buildings and their advantages. So I just got to show you the next slide here. I'll just skip through here. So basically, why is it not normal presently? So I want to compare this to the current situation of the pandemic. When something like this shocks the world, the scientists and doctors get together and it's an emergency, and they work together as professionals. Now, if you look at the coronavirus, millions of deaths. Millions have been affected and infected, and then the deaths are hundreds of thousands. But if you look at how the profession, the medical profession, is all pulling together. So you compare that with climate change. Climate change has affected 800 million people. Millions of species have died. And the biggest thing that we can affect in our profession and industry is buildings and carbon emissions of these buildings. I don't see our profession acting like doctors at this point. And if you think of the coronavirus as a cold or flu and it'll go away within a year or two, I would say, as an analogy, climate change is cancer that will pop up in 20, 30 years, and you can't stop it until it's too late. So that is the bigger challenge for today in our reset. So professionally, the World Green Building Council and the United Nations has mentioned and stated that by 2050, for us to stop the 2-degree temperature rise of our planet, we need all buildings to be carbon neutral or net zero by 2050. That's it. So what does that mean for us today? Well, you know what? That means that we need to design them today because they'll be around in 2050. And then we even have to retrofit the existing buildings to be carbon neutral or net zero. So zero emissions, everything by 2050. And that's to stop this 2-degree temperature rise of our planet. And of course, I do this. I've been doing this since 2006. I've been speaking about net zero buildings and designing net zero buildings since 2006. And I have a personal responsibility because I have a daughter. And I think that I need to do what I have to do as a parent so that the children, my daughter and their generation, can have the same lifestyle and standard of living as we have. And we can't just say, hey, that's their problem, right? So we need to act for the future generations. 57 net zero buildings around the world, presentations around the world also. I've done net zero buildings from cold climates like Canada to hot climates like the Philippines, Singapore, New York, Mexico, everywhere around the world. And we'll touch on a few of those today. So if we look at just the Philippine climate for building design, there's several factors. There has to be some urgency in getting these net zero buildings. There has to be more education, public knowledge, and this is what we're doing today. There has to be regulation. We have advanced energy codes here in Canada. It's not the topic for today, but that will help push towards this carbon neutral and net zero designs. Developers, they blame them or not, they hold the money and they basically say yes or no to these designs and regulations. So there's a lot of pressure on developers also. And then there's the design community, the construction industry. I think a bigger thing too is we have to be open-minded and open to new ideas. And then there's always a cost factor. And I think what we need to open up to is that there's always, we can't just consider the short-term gain and the short-term cost, but there's going to be long-term gain and long-term cost. And I'm not an expert, so I can't put a price to climate change. You know, what if we don't do anything? What is it going to cost us in the future? And I personally feel, and studies have been done, that it's very, very expensive, the damage that we have to pay because of climate change. So this is the net zero approach. I'm not here to give you too much detail, bore you with the detail of designing net zero buildings, but we'll go through just a few concepts. Recognize the design options early. When I design a net zero building, I basically get involved right from day one. The massing of the building, the orientation, the location on the site, that's very, very important. All that stuff is free. There's no payback analysis or anything. massing of the building can save you on energy and air conditioning cost in the future. Just the massing and orientation. Reduce energy demand. That is very, very important. You're looking at passive design. You're looking at all this stuff, and we'll go through this in greater detail. Remember the laws of physics and Mother Nature. Hot air rises, things like that. You know, natural ventilation, being resourceful. What we mean by that is in Canada, and some of these concepts are, I'm just generalizing. We of course, you have a floor slab that holds the floors up and the building. This floor is actually a thermal mass that keeps the building cool. So it serves two purposes. Anyways, we'll go through some of those concepts later. Recycle and reclaim. So any energy that you use, you have to think about it and you have to recycle it. There's ways of doing all that. And then the last part is you apply renewable energy, and then you decide what is the most feasible and low cost way of applying renewable energy to the project, and that's how you get net zero. So the biggest thing about net zero buildings is not the technology. It's not the solar panels or the wind turbines. It's the hardest part and the most innovative, and I guess the most cooperative thing that we need to work with in terms of the design team, engineers and architects, is how to reduce the energy demand of the building. And this is mainly measured by EOI, or energy use intensity. A typical building you could see is around 300 to 400 kilowatt hours per square meter per year. Most net zero buildings that I've designed are at 100 or below. And this is 80, 90% of the effort. You know, there's not much renewable energy, you know, in designing renewable energy systems. It's solar panels on the roof or things like that. That's just a checkbox or a technology thing that you apply. But the hardest part is how we need to work together with the developer, with the client, and the architectural team, and all the rest of the team, design team, to get the demand low. I am a big advocate of passive design. I'm a mechanical engineer. I'm an engineer. The last thing I think about is air conditioning and heating. That's the last thing. For example, for electrical engineers out there, first thing I think about is how to get maximize daylighting in this building. And then I look at LED and all these technologies. Passive design in the scale, we've proven this. As the building becomes more passive, the building becomes lower energy consumption naturally. And the cost of the building reduces. Passive systems are lower in cost than active systems. And then maintenance costs, operational costs, everything goes down. And then if a building performs passively, it's more comfortable. Okay, that means you use less air conditioning. So it all sums up. It's all basic stuff. So here are some of the common features of net zero or carbon neutral buildings. Integrated design, everybody understands that. We don't need to go into that too much. And here we go again, passive design first, not technology first. Natural ventilation I've seen on most of my projects. It's very applicable, even in the hot and humid climates of the Philippines. Thermal mass, I'll take questions on natural ventilation, on how comfortable it could be in a hot and humid climate, if there are a lot of questions and debate later. Thermal mass, radiant systems, that's common in other climates of the world. And then, of course, we look at local sinks. That means we look at things like underground aquifer wells that we can pump out through the ground, and we can use that for cooling. These are natural systems that occur. Can we use the seawater to cool our buildings? And then, of course, common for these buildings are on-site energy generation. That's solar panels and wind turbines. The biggest thing here also is there's a soft factor. That what I'm saying is that there has to be an inspired team. There has to somehow the project needs to hit a personal string. someone in the client team has a champion and they want a net zero building or else. This is a personal thing. And the reason why I mention this is most decisions are based on personal level. It's not a technical level. It's proven fact. Most people make decisions if it's personal. And if a project becomes personal for a team and a client to do the right thing and create change, you'll get a net zero building one way or the other. Okay, so the challenges of the Philippine climate. I just showed this slide here. One of the biggest challenges is not just the weather. Of course, it's the overpopulation. If you for the Canadians out there, Vancouver Island, what we have in British Columbia, the province of British Columbia, is as big as all the islands of the Philippines put together. And Vancouver Island has about 200,000 to 300,000 people. Philippines has 100 million plus. So that is a challenge. The other challenge that I see in the Philippine situation is the built environment and all the hard surfaces like concrete and so on and so on. I visited Makati a lot. I've been in the Metro Manila, and I've also compared and visited Singapore. If you look at how we deal with this concrete, Singapore has a lot of shade. Singapore is actually closer to the equator, and the people who has been to Manila and Singapore seems cooler, even though their natural environment is hotter and more humid than Manila. It's just Manila artificially becomes hotter. So that's some of the challenges. So this is coming back to the Singapore scenario, is how to deal with heat island effect. I don't know if this is true, but you come from the airport. I've always chatted with this with my wife, but there's a lot of trees on the highway, and it shades the highway. If you come from Changi Airport, these trees I heard came from the Philippines, and so it's kind of weird how Singapore uses these trees to reduce their heat island effect, and we should be using more in the Philippines climate. Solving radiant, so that's solar gain, and that's the biggest thing for air conditioning that we have to look at, and I'll go through a few examples. Humidity is a big challenge. So the biggest way or the easiest way to deal with humidity is air movement. So when it's humid and you are in front of a breeze, or the breeze is on your body, it cools you off. It dries the humidity. It dries the sweat off you. And that is how you solve the humidity issue. So if you're under shade and it's windy, even though in the climate of the Philippines, it's 40 degrees out and it's 80% relative humidity, you could feel comfortable. And I've been to a lot of resorts where there's no air conditioning, you're in shade, and there's an artificial wind breeze created by the architecture. That solves everything, and it's not air conditioned, and it's a high-end resort. So there you have it. So you could just shade yourself and be in the breeze, and you could be cool. And that is one of the Bahay Kubo scenarios. As you could see, the Bahay Kubo is what we call environmental responsive design. Before air conditioning, before technology, this is how the Filipinos kept cool. So if we generalize it, in hot and humid climate or tropical climate, this is the architectural design, how to deal with the climate. So it's heavily shaded with the roof. And then if you open the window, it actually pops up, and then there's added shade, and then you get the natural ventilation. It's raised up so that the cool air at the bottom of the Bahay Kubo gets cool air, and then hot air rises, escapes through the top, of the roof, and you get good stack effect and natural ventilation. Now, those are hundreds, maybe thousands of years old technology, and we need to modernize it and use these concepts in our buildings, and they can be used. Here's the perfect example. If you look at how you design churches, so I got involved with. I'm sure the Philippine people would be familiar with this. This is San Sebastian Basilica, and if you look at how churches are designed, those towers are wind towers, so they create lift or stack effect, and what that does is all the air comes through the bottom, which is cool, and then all the hot air escapes through the top. And the more stack effect you have, the more air movement. That means it helps with humidity when you could feel an artificial design breeze. So these are some of the concepts that we need to look at on the design in terms of net zero buildings. And by the way, without me mentioning, this is the basis of this is reducing energy demand and reducing our air conditioning load, because that's the biggest challenge in this climate. So passive cooling first, and if you've we love staying at the resorts in these tropical climates, Bali, Malaysia, Indonesia, not just the Philippines. But as you could see, some of these resorts are designed with no air conditioning. Some of the lobbies, and basically they're wide open floor plates with the air breezes creating Venturi effects and stack effect, fully shaded, heavy mass floors so that floor absorbs the heat. So, all of these things are old technology that we can apply for these buildings. So the lessons learned, some of the lessons learned, this is my former house, in near Ayala Labang on Danghari Road. I noticed right away, see the high ceilings. If you could see my mouse here, these are the high ceilings in our living room. There's no opening at the top, so the heat gets trapped in the house. If we had an opening there, it actually creates lift and stack effect, and that would have created breezes, artificial breezes, and then we wouldn't have this heat this hot air trapped that would heat up the ceiling. When the ceiling's hot, it would radiate towards the occupants and us. So that means we need to crank the air conditioner on. So it's as simple as creating stack effect and having openings at the top. Another thing I noticed is these what we call big ass fans, or fans that you have a lot in hot and humid climates. It's always rotating so that it blows down. That something as simple as creating an opening at the top and then blow up so that it relieves the air, and then what replaces the air at the bottom is cooler air. If they blow down, yes, you get the air motion and drying effect towards you, but you're blowing the hot air down, right, and blowing it back. So anyways, these are the kind of simple things that we need to look at on these designs. So now we talk about technology. So proven versus high tech. I believe in old technology, passive design, but then you have to balance. I'm involved in smart cities, smart buildings. There is a place for technology, and you need technology to maximize and optimize the building operation. And also, it's cool to have feedback, like talking to the controls. Hey, Siri, can you turn on my air conditioner? This is more of a human interaction. I use the analogy of the car. The wheel will always be round. That's passive design. But the inside of the car always changes, and the feedback, all the controls, this is the human interaction. That could be high tech. But, the aerodynamics of the car, those are basic science. I relate that to natural ventilation, stack effect. So all of this stuff works in some way in this high tech versus low tech solutions. I look at closed systems. That means I look at all the resources on the site and see how much energy we can or cannot use. And there's a perfect example of this, and I'll get into the project examples, is garbage. That's a waste. People just throw it away, but actually it's fuel for us to use for renewable energy. This is what we call integrated resource management. So we look at all the resources on the site, what can be used and reused and recycled. And here is the advanced gasification system. So basically we use garbage, you can use raw sewage, and that goes into advanced gasification, a 40-year-old technology. It's not incineration. And this, out of waste, you can produce carbon neutral air conditioning, heating, and electricity, basically energy. Quickly go through a few examples, and I'll just take questions because I'm going to really quickly go through these projects. So I was a part of a team with my good friend Angelo Minosa, and Dr. Ken Yang from Kuala Lumpur, and we won the Supreme Court building competition. So basically, this project here, we looked at open corridors for breezes and to reduce the air conditioning load, so we don't have to air condition the corridors. The glass that you see, this is what we call dynamic glass. So it tints automatically when the sun hits it. It's pre-programmed, and it's a dynamic tinting system. One of the systems we looked at was called View Glass. So the renewable energy source that we proposed here, since we did not have enough surface area for solar panels to make this a net zero building, was we were proposing to the Supreme Court judges when we designed for this design competition, was to have contracts with the local government, which is probably Taguig in the area, and take their garbage, which ends up in the landfill, and basically truck it underground, and we'd advance gasify the garbage, and we produce carbon neutral air conditioning and carbon neutral electricity for this site, and we create a net zero building. This is a project in Japan that we just started, and of course the pandemic put it on hold. I'm not sure if it's going to start up again, but so this is a whole about a $5 billion resort that we started very, very rough master planning and concept design, once again with Jello Minosa. And basically there's a casino, there's villas, there's a mall, there's retail. It's everything. It's almost like a whole little town. So some of the features is we looked at passive design. We covered up the mall with a covering to reduce solar gain, and have an exterior space unconditioned or semi-conditioned. And then the orientation, we looked as much as possible to create, to implement natural ventilation. Nagasaki, it has a similar climate than Vancouver. It's a moderate climate, so natural ventilation should work most of the year. And then we had a district energy system for heating and cooling that we looked at. We looked at maximizing solar panels on the site. We looked also on dynamic glass for solar shading. And then yeah, similar to the previous project, we looked at advanced gasification because it's such a huge site. Even if we covered the whole site with solar panels, we would not get net zero. We probably needed 4 or 5 times the area of this site. But we looked at waste and how to use that waste to produce carbon neutral power and energy. Now, the EUI on this project, or energy use intensity, we projected, because of the passive design and the efficient mechanical systems and engineering systems and natural ventilation, it was below 80 kilowatt hours per square meter per year. And these are very intense uses like casinos and convention centers and shopping malls. Hitting 80 is very, very difficult to do. But once again, it's conceptual work, and it was an estimate at the time. Another large project I'm working on currently, and once again got put on hold, is the Montreal Airport. This is a huge project. It's an expansion of the airport, and a major part of this project is the parking garage. We plan on putting a solar farm on there. And then also there is a lot of garbage on the site, once again, with combination of advanced gasification. Natural ventilation in an airport is always a no-no. Well, it's noisy, the planes make a lot of noise, but we looked at how we can implement natural ventilation for an airport. So you have to think out of the box. You can't just, do what has been done before and then create something different if you keep doing the same thing. So, and of course, airports love a lot of glass, and we looked at double facades on the project, and also comparing that with dynamic glass also. This is a landmark tower in China. It's another competition we won, and once again, I'm not sure if we won it because we proposed net zero, but the top of the tower will have wind turbines, because the height of the tower, as you go higher, you create more wind effects, and so wind turbines make it feasible. And then we line most of the facade with solar panels. It was a competition. It's very conceptual work for this project. And, the scale comes all the way down to single family homes. We looked at net zero buildings, single family homes, duplexes for a client in Toronto. This project here is in Washington State in United States. It's a passive house. And if you're familiar with passive house, it's very high in envelope performance, glazing performance. And once you have a passive house, it's very easy, because the EUI is so low already on passive houses that you can create a net zero building easily. This is one of the easiest projects you can generate in terms of net zero energy buildings. And then this is a project here in Vancouver, and this is a project in the Philippines, and this is the modeling that we did for that. We got the EUI down to about 49 for a residential house, and that includes air conditioning. And some of the concepts we looked at there is to insulate the house. We proved that insulation is required. It's not a typical construction in the Philippines. We looked at double pane glass. We looked at, things that hasn't been done. Well, if you want a net zero building and it hasn't been done somewhere, then you got to do something different. So we looked at that, and it doesn't show here, but we recommended wind towers to create stack effects. So when you open your window, you create Venturi effect and stack effect, and so we can generate higher levels of airflow for natural ventilation. This is the San Sebastian Basilica. So we looked at naturally cooling this building and how to keep it cool, even though it's a metal church in a hot and humid climate. That is a no-no in terms of construction. Metal will get hot and stay hot in that climate. So yeah, for a hot and humid climate, softer materials are probably better. But of course, I get challenged all the time because concrete is a major material that's used a lot in the Philippines, and of course, because labor is cheap and the materials, and it's more expensive to have, I guess, lower weight construction. So for this project, I'll just go through one concept that we looked at. We wanted to supply from the garden right beside, because cooler air is here. So we take like benches and we put grills, and then that air goes down below the church. There's existing tunnels under the church. We supply air at the low part of the church, and that's cooler air, and it's cooled by um, um, the lower heat island effect of the garden next door. And then what we do is we displace the air through grills, and we let the hot air rise. And we opened up these chimneys, including the one over the the priest. I forgot, what a bad Catholic. I forgot what it's called. The altar. Jeez, I was an altar boy since I was 16, and I'm gonna get in trouble. Anyways, sorry, until I was 16, I was an altar boy. Yeah, we open that up and we create more breezes. Now, you can't compare this to air conditioning this church. There's no way that you can compare a naturally ventilated metal church and compare that to the comfort of an air conditioned church. But you would save millions of pesos per month for not air conditioning his church. And from this design to what it was before is a huge improvement. So anyways, this is Mandani Bay in Cebu. So what we did there, I'm just reading the comments. I just had a laugh. Anyways, we'll share that with everyone if we have time. So Mandani Bay in the Philippines, we were part of the master planning group. Originally, it was the master planners were out of Australia. Mandani Bay was a partnership with Hong Kong Land out of Hong Kong, and a Philippine group, Taft Properties. So we provided a sustainable master plan and how to get the whole site to be net zero. So these are multiple high-rise buildings. Some of the features we looked at was how do we looked at the local climate and how to design this for wind breezes, and the wind breezes go this way. So we aligned the building so that the wind breezes passes through the buildings freely, and it creates more of a walkable community. And then that could be utilized for natural ventilation for the buildings. You could see the orientations of the buildings. We tried to make sure that we have less east and west orientations of the glass. We tried to limit the amount of glass for the project. I know that that's a challenge because you want to sell for the views and daylight. I get that. But then we tried to balance that out. We looked at, once again, because this is such a huge site, we proposed using the solid effluent from each STP or sewage, and using that solid waste and turning that into fuel for advanced gasification. Another interesting thing about this project was the site was smelly, and they asked us, what can we do? So what we found out was the effluent or the garbage or things in the water, the creek beside it, was making it smelly. And what we did was we proposed a system where we filter all the sludge, and guess what? That sludge is carbon fuel for advanced gasification. So once again, it's this closed system approach on how to make these buildings net zero. This is a resort in Sri Lanka. We looked at the water temperature and see if we can use the water and the sea breezes to cool the building. We look at orientation, massing of these buildings on a master plan level, the sun angles, so that we can eliminate or reduce air conditioning in this hot and humid climate of Sri Lanka. This is another church that we did. This one's in Toronto. Of course, there's heating. These are those concepts. This is not just a bell tower or a display for the cross. This is a wind tower. and it creates lift. And once again, this is the air handler. Can you imagine? This is the air handler. And I've done a lot of research. Michelangelo designing St. Peter's Basilica. There's common themes here. I speculate that there's no heating or cooling in that church, and it's been around for thousands of years. So, looking at these old technologies and how to implement them for newer construction and making them more sexy and more modern, that's that's the challenge, and because these are proven technology. Other than things I like dynamic glass and advanced gasification, solar panels. I haven't talked about air conditioning systems, right? It- we the main goal here is to reduce these air conditioning systems so they're simpler. Like it could be just a fan inside the building, keeping air moving. There's a lot of talk about VRF and these compressors. I'm a mechanical engineer and I can't keep up with these things, right? And that's why I don't talk about them too much in my presentations, is because if relying on technology, it becomes obsolete within a few years. It's like your iPhone 12 is coming out, my iPhone 8, whoever has an iPhone 8, guess what? It's going to be obsolete. So I design these buildings more simpler, more passive, and more on the proven technology, because you can reduce energy demand of these buildings, daylighting, right? Use windows for natural ventilation, and so on and so on. And this relates once again back to the Bahay Kubo, right? And churches. This is the Olympic Village that I did. This is a net zero building for the 2010 Olympics. It has solar panels on the roof. Um, Typically, a residential building would have a double loaded corridor. The corridor is in the middle, and then you have suites on each side. I put the suites on the outside, but this is done in Asia a lot, and we don't have to air condition the corridor. And then also that corridor that hangs on the south side, exterior corridor, becomes the shading feature for the south windows. So it's simple stuff, right? It's common sense sometimes. This is a large community in Toronto, 120, 150 acres, and it's a huge net zero community. They have huge aspirations. It's going to be a smart city. This is the sewage treatment plant for the nearby area, and we're trying to use that as fuel. That was proposed. So this is in basic master planning right now, concept design. This is a project in New Mexico. It's a head office for a parts company, car parts. As you could see here, they didn't want to reduce their glass percentage for a hot and humid climate. So we with the architect, designed this feature. The light can go through here, but the solar gain is reduced a lot. So it's all about the diameter of the holes and the spacing of the holes. So the lights go through, but the heat doesn't get through. This is a project on a volcano. They wanted a resort on a volcano. But anyways, it's going to be a net zero project too. Project in LA. I think it's about time to take questions. 5 minutes. Yeah, 1 minute. So this is a project in LA. We're using absorption chillers. So solar panels power a chiller, and we use radiant cooling. That means we put this cool water into the slab, and that's how we get natural cooling. We basically use that concrete to cool the building. So being resourceful in that way, and then we inject a little bit of cold water that's produced by solar through an absorption chiller. So this is an office building in LA. To be a net zero building, and that's the heating and cooling system for that building. This is a campus in New Mexico. It's a government campus, and this is the master plan. And basically what we did there was, how do we share energy? So some buildings are on cooling, some buildings are on heating. Some sides of the building's on heating, some sides of the building is on cooling. So how do we regenerate the energy and recycle this energy before producing the energy to and using carbon fuel? So that's this project here really is a testament of how we can recycle energy. This is a daycare, 5,000 square feet. It's a living building. It's a net zero building. So I'm just demonstrating to you guys every type of building. We can't go through all 57 projects, but this is some of the more interesting ones. Some of the other ones are quite boring, I tell you. This is Regent College Library. That is the wind tower that we designed. That's the air handler for the building. There it is right there. That's an architectural design of a wind tower. We put an aerodynamic top. As the wind blows across the wind tower, it creates lift and wind pressure, and that's how you create natural movement within your space. This is a high-rise building in Vancouver. We have these little, every 10 floors. You can't have natural ventilation because of the stack effect of this height of this building, so we break it up for every 10, 15 floors. And then you have this outdoor garden that people can congregate and have their lunch and so on. This is Van Dusen Garden in Vancouver. All the air comes through the perimeter, goes across through goes across through the corridor and then up to the wind tower. If you Google this building, the wind tower is beautiful. The way the architect designed it. As you could see here, there's a style that's coming up. Natural ventilation, wind towers. These are old technology, and architects will have lots of fun designing these things. You should Google, and I don't have the slide here or a picture. Incheon Airport. Incheon Airport has this wind tower right on top of it. It's beautiful the way it was designed. I'm not sure who the architect was. It could be Foster's or somebody. College of the Desert, Palm Springs. We did the master plan on how to be a net zero college facility. And of course, I want to end off, the biggest thing that I see for these net zero buildings is there has to be a champion. It's not just me. I can't push this alone. There has to, once again, have, we can't create change unless it's not on a personal level. Things are always about leaders, and these are some of the leaders that I've looked at. And there's a religious leader, of course. Apple have changed the world, and it's all about Steve Jobs and his vision. Simon Sinek, you should see Simon Sinek here. And of course, if you've seen Lululemon, he went from a net worth of 100,000 to 10, I don't know how many billion now. And it's all about selling yoga wear and health and fitness. So anyways, it's all about, the personal level of how to create change. Okay, so how can it be a norm? I think, us professionals, architects and engineers, we need to act like doctors. When there's a crisis, doctors work together, and they have a common sort of front. I think now we need to create this front as architects and engineers, and we need to tell our patients, and with all due respect, developers are our patients, and we need to provide the proper advice to our patients. And lastly, these are that is my contact info. I really love this quote that I got from my sister a couple of months ago, maybe a year now. The world will not be destroyed by those who do evil, but those who watch them without doing anything. That's powerful. So anyways, and of course, the theme of most of my projects is trying to keep it simple. And the reason why I like simple things is so that you don't overwhelm clients. So anyways, the greatest ideas are the most simplest. So I'll end off there, and I think AJ will be on.
All right? So we are Back with our altar boy. Father will be very pleased. You remember his altar.
Can't believe I forgot the name of the altar.
Anyway, that was simply intelligent, Albert. I just love your presentation. I myself, I'm an architect, and it is a standard amenity. The Venturi and the stack are always standard amenities in our project. So thank you for that. But before we go ahead with your questions, I just want to thank our partners once again. So thank you to Adobo Magazine, our official media partner, and the British Council, and of course, Bensalido Architects, our event partners. Okay, earlier we asked you a poll. So let's see our results. All right. So the question is, in this day and age, would you consider living in a bahay kubo? So it is a resounding clamor to live in a bahay kubo at 91.67%. I wonder where the 8.33% would want to live. Anyway, so it is something that we can look forward to, especially after hearing Mr. Bicol's presentation. So now that's out of the way, we can proceed with a question and answer for Albert. All right. Where do I see the first question? All right. So we have the first question here, Albert, from Mr. Guevara. How do you think the net zero energy scheme will fare in the Philippines, especially in Manila? What specific materials and mechanisms could we use for passive cooling for the urban setting?
I think because I've worked with, let's tackle the elephant in the room, and it's like developers like, and it's all due respect, like Ayala and all these large developers, they already have, uh, um, I guess, a mindset that air conditioning is luxury.
Yes,
And we all know, as a Philippine culture, you go into the malls, it's cold, and that means it's a nice mall, right?
that's right.
We That's the first thing that needs to break down, okay? Because and if you see the what's wrong with that is the fact that, why do people wear sweaters in the Philippines? Because we overcool the buildings, and that's a waste of energy. So there has to be a cultural shift, and I always talk about this, and you'll have people talk about this. In Canada, we're looking at rising the temperatures for cooling. Instead of 24 degrees, it'll be 26 or 28 degrees. Wear shorts to the office, right? Yeah. So let's start with that, and that is free, and that saves a lot of energy in itself. But anyways, that's a challenge. That has gone through deaf ears in my past. So, um,
Yeah,
so anyways, so the materials. The,
yeah. What
concrete
specific
is
materials? Yes.
concrete is a dead end, in my opinion, in the Philippines, because concrete absorbs heat. It's a mass that is it's a material that could be used in colder climates, or climates that is cold at night, warm during the day. So the concrete cools at night, and it provides cooling during the day. In a hot and humid climate, the concrete gets hot during the day and stays hot all day and all night.
That's
So
right.
it's so now you have to, the thing for me, and when concrete is the solution. And I did the mine museum with, I'm
Yes.
sorry,
Ed
uh,
Kalma.
Edcom. Thanks, AJ. Um, I recommended to insulate the concrete from the inside, so that it's away from the inside surface of the building.
That's correct.
So some of those steps, passive cooling techniques, I've said it to death, right? At natural ventilation, can we use that? The Bahay Kubo concept. Um, to be quite honest, the first thing I read, or when I was in the Philippines, when I returned, when I was a young engineer, is I met Bobby Minosa. And I went into his office. He was such a nice man, and he showed me his book, and I read his book. And till today, my favorite building is the San Miguel building. You look at the
Yes,
angle glass, the sun hits it and it reflects back. That's the
exactly.
that's the shading scheme. This is all about sun
That's
angles.
genius, right? Yeah.
Yeah, these things are all about the local environment and how to design to the local environment. So, anyways, I hope I answered the question. We don't have
Yeah,
all day to do this. So,
of
anyways,
course, of
move
course.
on to the next question. Yeah.
Thanks for that. So we have another question here. Oh, all right. This is from Cebu, from Dennis Mayo. In the context of the Philippines, how does implementing net zero design impact society in the grassroots level?
So, sorry, AJ, could you explain the grassroots level to me? Is it,
I
can you?
think what I think what Dennis wants to ask here. He meant grassroots, meaning the large chunk of the consuming public who may not have a lot of control on who will design their buildings or their houses or their condominiums.
Right.
Essentially, yeah, the man on the street.
Yeah.
So he is asking, how does uh, how does NZE impact someone, the man on the street, and how can this be relevant, or how can he uh, make this useful in his everyday life?
I think most of, let's say, the basic design, and I don't want to, I'm not insinuating anything, but if you look at the squatter areas, the major housing types, there's no air
Yes,
conditioning. So it's a start already. The culture already knows that there's no air conditioning. So, the energy intensity is all about lighting and maybe a TV or refrigerator, and a little bit of solar panels can be net zero. It's actually easier to do these types of buildings than doing a Glorietta mall or
that's
a
right.
mall with all these people and lighting. So the grassroots level, it's an easier, but they have less money. I get that. But I heard in the Philippines that you can actually rent your roof to solar panel companies. They can
Hmm.
actually put their solar panels up. You can claim to be net zero, and they can sell their power to Meralco or
Yes.
whatever. So there's a business opportunity there, right? To actually rent your roof that they have there. And I see a lot of roofs being plunked out during the storm, anyways, in that area, so they can solidify their roof. So there's a benefit for them also.
Yeah,
Um,
and I think
yeah,
I'd like to reinforce what you said before you close, that the simple solutions. I think you mentioned something about that, the simplicity of solutions acquire this importance as well. I mean, the man on the street doesn't necessarily have to reinvent the wheel.
correct.
Yeah.
Yeah, I'd like to
And
add that what I'm really proud of is one day something came up. Someone showed it to me. It's a bottle with some liquid in it, and then they used it in the squatter area to create
yeah,
daylight.
yeah,
And that
that's the
was
project of Ilak Diaz. He's actually listening. He's online right now.
that is the perfect example of how we can use old technology and just use our innovation, and it's incredible. And I was so happy to hear it came from the Philippines.
That's right. Yeah, that was. I love that project.
Yeah.
Anyway, I have another question here. Well, this is. Yeah, I'd like to ask you this question. This is from Tonic Madulid. How can the Philippines adapt this net zero approach when we are struggling with the basics of reducing carbon footprint?
Yeah. Well, you, adapting the net zero approach is reducing carbon footprint,
All
and
right.
the like I said over and over through my presentation, the hardest part of a net zero design is reducing energy demand. You know what? If you don't meet net zero and all you need is solar panels, that's the last step. That is actually the final step and the easiest step. The hardest step is reduce energy demand. So if you could design that, and every architect in the Philippines has the skill to do this,
That's
that
right.
reduces the carbon footprint. So if we don't focus on net zero, and net zero will come around, And that's why in Canada, we design net zero ready projects. That means it's only missing renewable energy because that's expensive. But everything else in reducing energy demand, passive design, and all this stuff, natural ventilation, that is actually either the same budget or below when you compare it to a standard design of a building. So I don't, you could take away the cost factor in reducing carbon footprint. Okay. Net zero is zero carbon footprint, but that could be the last step. And that's the expensive step.
Yeah, I understood. Yeah. So there's really need to be a clarification that there's really no distinction between the two. It's a step. Is that what you're trying to say? The first step is attending to carbon neutrality, and then the final step is ultimately a net zero balance.
Correct.
Okay. I have my own question before I read another question from the audience. Albert, are you familiar with the Jevons paradox?
No. Explain it to me.
In my own research about sustainability and energy management, they have this paradox called Jevons paradox, wherein the behavior of the occupant, a human being who knows that his building has been designed to reduce energy or reduce consumption of resources, actually overcompensate by spending more resources. Let's say the occupant knows that the water from the tap has been recycled from the septic tanks of the building, or from the rain, from a rainwater management system. So what this paradox is saying is that the human being, knowing this, now tends to neutralize or negate by discompensating by using more of this water, since he knows it is free. So what do you say about that? Have you encountered it? And if you do encounter, or if you call it some other name, how do you manage it?
I have encountered this, AJ, and it's a great question. So I designed that net zero building in the Olympic Village, and it had bad press because the people, because the occupants know it's a net zero building, they consumed more energy.
Exactly.
We live in this net zero building, so we could leave our lights on and we could do this because it's all free and all this stuff.
Yes, exactly.
And what the bad press that we got was this building consumes more energy than anything on the site, and it's the net zero building. And it's the Olympic Village, and it has a lot of buildings that we designed. And this net zero building has the highest energy consumption of all the buildings, or energy demand. So what we did there, okay, how to get around that? And let's start from the beginning. It's what we call manage expectations. So as an architect or an engineer, we need to right away get involved with the developer and the occupants to say, this is going to be a net zero building, and this is how it's going to work, and this is what you're going to expect. It's basically reducing, because they're expecting something and they're getting upset because they didn't get something. They compensate or they complain or whatever. But if you manage that expectation from the very beginning, and everyone's in line with the intention and the goal of the project for climate change and things like that, everyone goes on board. And sometimes, AJ, this is great. This is a great thing you brought up. When you manage expectation, there's less complaints. And people, even though it's a little bit warmer in Glorietta Mall, but it's a net zero building that everybody knows, they're okay with being a little bit warmer. They don't complain. They don't complain to the Ayala management, right? Because they know it's a net zero building and it's going to be a little warmer. So managing expectations goes a long way.
So this really comes down to a software control, or it's an administrative control, really, because it really needs to be holistic. It cannot. I mean, the engineering solutions cannot solve the problems of the universe.
We also inspire the occupants. What we do in some of our buildings is we put a huge display in the entrance, and it says, we've saved this much carbon we've saved this much energy in this building, and you are part of it because you're the occupants. So you empower the occupants of this building for feedback. And this is where
That's right.
technology comes in. Because if you don't tell people how the performance of the building is going, no one knows. They
That's
don't
correct.
care. They won't care. They just won't care.
Yeah.
Right?
I have another question from Joseph Kua. Can you please share good examples of sustainable buildings in the Philippines, or maybe future projects we may champion so we can have this movement rolling in the country? Or can you suggest small projects LGUs can start with on the islands that may easily follow the NZE philosophy?
Okay. I would suggest we start with organizations that have head offices, because that's leadership. For example, if Moralco is doing a head office, because it shows leadership, and leadership creates followers, and it's an example to the country. Big corporations, it doesn't have to be big corporations. If I don't know, the Boy Scouts of the Philippines head office, right, or the library or the Teachers Association of the Philippines, their office. You start with people that are in leadership. I don't want to touch on the government because we know from the Western world, we know how the Philippine government is, so I won't comment on it. But if we continued the Supreme Court building, that would have been an example, right?
Mm-hmm.
And it would have been net zero. But I don't want to get into it. Everybody knows it's
Yes, yes,
controversial.
yes.
But anyways, that's my solution to it. Is start with big time office or head office or corporations or associations that show leadership, and then everyone will follow after that. That's my thing. UST, most college campuses, because most of the people that operate these campuses are very educated anyways. They understand net zero. Go for it, right?
Yeah.
Library, the engineering association, the architects building, the next building for UST or whatever the universities are. Start with that. To start with like low income housing and things like that. It's a challenge because then you got to solve the financial issue and all this stuff. Start with the low lying fruit, right?
Yes.
I
So
would
essentially,
say, I would
yeah,
say,
go ahead.
without being controversial, San Miguel Corporation head office, what the old one that they have, or some head office, they have the money and they want to show off what they can do, right? Show to the Philippines what you can do. I challenge them, right? And then they'll
So
lead. They'll be leaders.
we start with essentially with the multiplier projects, as you're saying.
Yeah,
Yeah.
yeah, yeah, yeah.
All right. I have another question here, very related to the question or your answer about climate control, but this is more resolute in particular. From Maria Rita Matute, how do we exercise the Philippines' obsession with air conditioning?
Yeah, it's managing expectation and education. It's difficult because it's to change culture. It's
Mm,
very it's more psychological than an engineering issue, in my opinion, because of what I learned when I first started working in the Philippines. That air conditioning or cold buildings means luxury in higher society. So we
that's
need to
correct.
get beyond that. We need to get
Mm,
beyond that. In North America, that's not measured at all. Just because your building is cooler than others. In Canada, it's winter, so if it's colder, that means you're poor. But anyways, it's a strange paradox there. But anyways, yeah, I think that's the biggest challenge is managing expectation and understanding how to curve the culture of the Filipino. That um,
yes.
there is a science to this. Going from 30 degrees outside to 19 degrees inside in a building is not healthy.
That is
Okay.
traumatic.
Yeah, it is. And that's typically what happens in the Philippines.
Yeah.
Because you're subcooling these buildings, right? If you try this, if you go from a 30 degrees outside and 26 inside, you actually feel dramatically cooler. A 4-degree temperature difference. 26 is not cool, but because you're coming from a hot and humid space but the problem is it has to be mass, right? It can't be
Correct.
comparable. It can't be an SM mall is 19 and an Ayala mall is 26. Of course, everybody has to follow the culture shift of things.
Yes. Yes.
Yeah.
But one fine example of what you are actually saying is what do you call this, high street. You've been to
Yeah.
the BGC, right? It's
Right.
that formula of a shopping mall is not really too radical. It's how we've been shopping before in the 80s, and they just brought it back. People seem to respond to it with the no aircon but park setup. So yeah, I believe that what you're saying has an imminent future, especially with what is happening with the pandemic now, when we are very conscious about our resources.
Well, if you brought up a good point, the pandemic, it's safer to be outside
That's correct.
than being inside, and air conditioning systems are not ventilating properly. All they're doing
Yes,
is cooling, but not providing proper ventilation.
that's correct.
It has to be rethinked. And this is a whole presentation. As a mechanical engineer, I can present on healthy environments and against air
Yes.
conditioning. But your example is perfect. I have another stunning example for you. I love the church in the Ayala village. It's air conditioned. I
Which one
forgot
is that?
the one in Ayala village. Is it St.
Which
Peter's?
village?
Ayala
Uh,
Alabang village.
all right. St. James the Great.
St. James, yeah. It's air conditioned. And we go there a
It is.
lot.
Yeah.
It's very good. But we love going to the naturally ventilated church in Greenbelt.
That's correct. Yeah.
And that is outdoors. You have the proper design. You get the breezes going through. It's in a climate where there's a lot of greenery and shading. You know, yes, St. James, it's air conditioned, very comfortable. It's
That's right.
uncomparable. But when the one in Greenbelt, it's packed. It's comfortable, relatively comfortable. So
You are
there's your
absolutely
perfect
correct.
example.
Yeah.
Perfect
I do
example.
remember my experience with both churches in Greenbelt. It is humid, but it is comfortable.
Yeah. It's not
I
like
do.
it's empty because it's too hot. No, I go there all the time. Every time I go there, it's packed, right?
Yeah. All right.
Yeah.
This is my own question. It's quite a little technical. I'm asking this in behalf of all the designers because it's been my challenge as well. So I advocate for this gospel that you're saying as well to the clients. And a really intelligent client confronted me one time and asked me if you are not going to build the control, because there's always a promise, right? Yeah, when we do this net zero or this environmentally sustainable design strategies, we promise a reduction of energy. We promise something like this. So it's always a percent against a particular what could have been. My client asked me, but if you're not going to build me the what could have been, how do you measure that you are successful if the what could have been does not exist? Let's say, because we are designing, let's say I'm designing a house. So I design, the what could have been is I don't design this house with passive cooling. I design it as, yeah. And then I design this house with a promise of passive cooling, with a promise of energy management. But she asked me, how do I, because she's a scientist, how do I know that your promise is fulfilled if the control, which is the what could have been, the house that was inefficient, was not built? Scientifically, she said, there will only be a good comparison if the two identical houses were built as a science experiment, as a science
Yeah.
laboratory experiment would. What's your take on that?
Well, the simplest answer to that, AJ, is there are historical data
All
already.
right.
and you can rely on that historical data. I showed a slide. Most buildings are between 300 to 400 kilowatt hours per square meter per year around the world. It's proven fact. There's thousands of buildings they measured and all that stuff. A house in the Philippines, I think what we looked at was about 200 kilowatt hours per square meter per year, depending if they have a lot of air conditioning, how they use it. There's a lot of factors involved, right?
That's right. That's right.
But
That's right.
when you're talking about net zero design, we model the building, okay, and that is a measurement at the design stage, and then we put in controls, like you said, so that it will perform the way we modeled it.
That's correct.
And then when we model it, we compare it to the historical data, and then we show the client, okay, if you did it this way, it would cost you this much on aircon cost, and this
Yeah.
way on a net zero building, and that's standard way, payback analysis and things like that. But AJ, what I find to get around that issue of payback analysis and all that is that once you become more passive and more natural systems, it becomes cheaper. The building is lower cost, right? Instead of having ductwork everywhere and VRF units and stuff like that, you're relying on an operable window with a wind tower, proper design, and maybe a fan, to create air movement. Systems are simpler, easier to maintain. So that's a selling job to the client.
That's
now,
right.
AJ, you can't forget, your house is not air conditioned, so you cannot come back to us and say, "Oh, my brother's house is so much comfortable than mine." Well, it's air conditioned.
That's correct.
There has to be an expectation. You want a net zero building, it's not going to be as cool as an air conditioned building, right?
That's right. That's right. Of course. Of course. So, for our last question, this is from Mark Joseph La Ceste. Essentially, what are the parameters that we need to consider in designing the future? I choose this as the last question because it's what's the future for NZE? What's the moving forward, especially with this great reset of the pandemic?
I think it has to be a norm design. So that means that there's several factors. We have to affect regulation. That means that, like in Canada, we're getting to net zero buildings already as a requirement by the government. So, that is a good step. Another thing is that the design community must work together as doctors to combat this. This is our pandemic, right? Climate change is architects and engineers' pandemic, right?
That's absolutely true.
So, can we design as a norm a net zero building or something that has low energy demand and all that's missing is solar panels? And that is a normal design for architects and engineers moving forward, and applying all these parameters and design concepts. We need to work together. AJ, you know how to do this. I could talk to any architect and we work together. It's not difficult to do. I think some of the barriers that people see is cost. It's always a big thing is cost. How do you get around cost? So that is another concept that we have to look at.
That's correct.
So I hope I'm answering the question, but regulation has to be rough regulation, and then the professional industry has to move forward on this, and that's how we need to design in the future.
That's right. I completely agree with you, Albert. Legislation actually needs to come in so that it becomes a way of life. Because there's no way that we can coerce the consuming public to put our design. But legislation can extract that behavior out of the public.
Correct. And the other factor is, like, if AJ, you design a net zero building and then you recommend that to your client, or don't say it, but it's almost a net zero building. It's the way I design buildings. And then he tries to fire you because, I don't want a net zero building. Why are you forcing this into us? Then he goes to the next architect, and I'll use my good friend Jello, and he designs the same building. So if we all work together, and this is the common goal for all of us, like doctors, I think that will create a big movement, a huge movement, right?
Very well said, Albert. Thank you. Thank you. So that's our final question for Albert today. I know I'm not the only one whose interest got intrigued by this session. This is very, very timely as well. With all that's happening in our environment, there's a great need for us to pivot to greener alternatives. Again, thank you to our speaker for today, Albert Bicol. Thank you so much. Let me first thank as well our partners. Thank you to Adobo Magazine, our official media partner, and the British Council, and Buen Salido Architects, our event partners. Don't miss the next event headed by the British Council at 4 p.m., Hacking the Creative Hub Leaders Toolkit 9. We'll make sure to put the links on our social media pages for that. Catch us again at 9 p.m. for another interesting session, this time with Julia Watson in her session Design by Radical Indigenism. Do not forget to follow us on our social media pages for more news and information on IDC 2020 and our other programs. Share this event to your designer and non-designer friends by using our hashtag IDCPH 2020 or hashtag Better Normal by Design. So this is AJ Javier, and I wish you a good day and thank you for listening.